Okay, so let's go through some additional examples of using recursion. So we're going to write 3 void methods, meaning recursive methods that do not return a value. We want to make sure with each one of our methods that it has a base case and a recursive case, and that that recursive case somehow moves us towards the end of the problem, so moves us towards reaching the base case. So first we're going to write a program that counts down from some number from 0 and prints each number. I'm going to put all of these methods in a single class. So here's an example of something that would be very easy to do with iteration instead of recursion, right? So we could very easily have a method that looks like this. And uses a simple loop. We could use a for or a while. Actually, I'll use a while. And what it does is you send in a parameter to the method. It just says as long as that parameter is greater than or equal to 0, we will print out the number and then decrement it down. So when we exit the loop, n will be 0, assuming that we're calling n with a positive or non-negative number. And then at the end, we'll print out blast off, something like that. Okay, so this would be an example of an iterative countdown method, and we can then invoke it from main with, let's say, 5. So we have our 5, 4, 3, 2, 1, 0. And actually, I need to have my while loop iterate as long as n is greater than 0, since I'm decrementing inside the loop. And then we will count 5, 4, 3, 2, 1, 0, blast off. Okay? So that would be an example of my iterative version. Now let's write a recursive version. This is a problem that's pretty easy to solve with iteration, so you probably wouldn't solve this problem with recursion, but we are going to do it as an example. So we're going to write a method, and it's going to be void, again, meaning it doesn't return a value. So we always want to make sure we're thinking about the base case and the recursive case. And the recursive case should reduce the problem size and move us towards the base case. So let's start with the base case. How do we know when we're done? Well, we know when we're done if n, if the number you send in, is equal to 0. If n is equal to 0, we want to print out blast off. So that's our base case. So what is our recursive case? Well, our recursive case is going to be n is not equal to 0. And again, I'm assuming here that we're invoking this method with a non-negative number. If you invoke this method with a negative number, you're going to have problems, just like you would if you'd invoked the iterative version with a non-negative number. I'll let you think about the checks you'd need to add to account for that. But let's just assume that our user invokes this method with a non-negative number. Okay, so in our recursive case, we're saying, well, counting down from some number, let's say 5, is a really hard problem. I don't know how to solve that. But what I can do is I can print out count off the current number, and then pass a smaller reduced problem on to solve later on. So what I can do is I can say, okay, let me print the current number, and then the way I solve the reduced problem is by calling the same method, so calling the recursive method with a reduced problem size, and my reduced problem size is just going to be n minus 1. So this is the small part of the problem I'm solving now. And this is the reduced problem size that I'm passing off for later. And the way I do that is by invoking that same method. So if I change my invocation now from iterative to recursive countdown, we get the same print off, only with a stray parenthesis. Get the same print off, 5, 4, 3, 2, 1, 0, blast off. So again, we have our base case, our recursive case, and the recursive case does two things. It solves a little bit of the problem now, and then invokes the same method to solve the rest of the problem later. Okay, so there is your first void method. The next void method is writing a method to display the contents of an array. Now again, this is a problem that's pretty easy to solve with iteration. We can write a simple for loop to go over our array and print out each element, but we're going to look at how you'd solve it with recursion. So what we want to do is write a method, and it's again going to be void because we're not returning anything, we're just printing out the contents of an array. Call it print array, and in order to print out that array, I just need you to send me the array. We'll assume it's an array of integers. Okay. Now, oftentimes in recursive methods, when you're dealing with things like arrays or lists or any collection of elements, oftentimes what you need to do is you need to create a private helper method that takes in some more parameters. So if we want to write a method that someone else can use to print the array, we don't want that to require them to give us anything other than the array. The only information they should have to send in order for their array to be printed is the array itself. But if I decide to solve this recursively, I need a little bit more information to do that. So what we really want to do is we want to say, okay, printing an array is a hard job. I don't know how to do that. But what I can do is I can print one single number from that array and then figure that that position of the array is done, and I can pass all the remaining positions of the array off to be solved later. So what I really need to keep track of in my recursive solution is where in the array I am, right? Because we don't want to constantly be creating new arrays to send because we're really not changing the array. We're just kind of changing what part of the array we're looking at. So what I'm going to do is I'm going to create a private helper method. I'll call it print array helper. And that method is going to take in the array and then also two positions. Or in this case, actually, we'll just take in we'll take in two positions, and that'll allow us to actually talk about how we could customize this method a little more. I'm going to call them first and last. And essentially what this private helper method is going to do is it's going to keep track of where we are in the array. And this helper method is going to be the one that's recursive. Okay, so our method that the user would invoke is not going to be recursive, but it's going to invoke a recursive helper method. So let's start with our base case. Well, what would our base case be? What would be a really simple thing that we could say, oh, that's an easy problem, I know how to do that? Well, if we were only looking at a single element in an array, right, if let's say someone passed us an array that was only one element long, that's a pretty simple problem. I can solve that. So if my two indices are the same as each other, that basically means that I'm essentially looking at a one element array. Okay, I can solve that. And what I can do is I can just print out numbers at that index. So that's my base case. Now let's look at my recursive case. So my recursive case is going to say, well, I don't know how to print a whole array. That's a really hard problem. What I want to do is do a little bit of the problem now and then pass off a reduced problem to solve later. So the little bit of the problem I can do now is I can print the current number that I'm looking at. Okay, so that solves a little bit of the problem now. But then I still need to solve the rest of the problem, and I'm going to do that using recursion. So what I can do is I can make a recursive call to my helper method, sending along the same array. So I'm not changing my array. I'm just saying here's the same array that you can use. But now I've already solved the array that I need to print no longer spans from first to last because I've already printed the element at first. So now the array spans from first plus 1 to last. So this is how my problem size gets reduced because I've incremented first up one. So initially at first is the beginning of my array. Now it's one element in. And when I call this method again, it's going to be another element in and another and another and another. Okay. So eventually that first, if it continues to be incremented, will equal last. And so this part of our recursive call is moving us towards the base case. So now the last piece that we need to do is we need to figure out what are the initial values that should be sent to this recursive method. So we need to invoke this method from our print array. We need to call our helper, and we pass along just our array. Now what should first be? So what's the first element of our list that we want, or our array rather, that we want to print? Well, it's 0, right? We just want to print whatever the first element of our array is. And what should last be? Well, the length of our array is numbers.length. But let's say we have 5 elements. That means our indices go 0, 1, 2, 3, 4. Numbers.length is going to be 5. Do we want to actually go until first equals last if last is 5? We don't, right? Because that would make us try to print out the element at position 5, and we know that that element doesn't exist. The highest index is position 4. So we actually want the initial value of last to be numbers.length minus 1. So now I can create an array. Whatever, and invoke print array. And you can see that it prints off all the numbers. So again, what happens is the print array method takes in a single array and invokes a recursive helper method, and it sends that recursive helper method some additional information that we need to solve the problem recursively. This will happen a lot whenever you have recursion dealing with arrays or lists or things like that, collections of, of data. We often need some indices to help us move through that collection, but we wouldn't want our print array method to have to take those indices in as parameters, because someone else calling the method, they shouldn't have to worry about that. They should just say, hey, here's an array, print it. But then when we write our method, we have to think about what those numbers should be. So we send in the first and last indices, and we then write our base case, which is when those two indices are the same. That means we're done. And we write our recursive case where we print one little part of the array and then increment so that the next call prints a reduced size of the array. And again, we're not really changing the array, we're not reducing the size, we're just kind of moving those indices towards each other so that it seems like we have a smaller problem size. Okay? So that is our print array method. And next we're going to look at a method to print the contents of an array backwards. So there's actually one really tiny change I can make to my existing helper method to make this method print the array backwards instead of forwards. I'm not going to tell you what that is. I'm going to invite you to think about it and post your answer to the discussion board. And I might consider giving one or two extra credit points to anyone who does that. You just got to think a little bit about how recursion works, and there is one simple change you can make to this method. I will say it's not, I won't say anything else. I'm just going to say there's a simple change you can make here that would convert this method from printing the array forward to printing the array backwards. But we're not going to do that. We're going to write a new method so that we can just get a little more practice. So we're going to write another method. Say print array reverse. And again, we're only going to take in the array as a parameter because someone calling this method shouldn't have to send us any other information. They should just say, here's the array, I want it printed backwards. But for me, to write that method, I need some more information to keep track of things. So I'm actually going to write another helper method. Helper methods are private. And I'm going to, again, take in some indices. So here what I want to do again is the same approach. I want to print a little bit of the array, and then now, that's the part of the problem I'm going to solve now. Then I want to reduce the amount of the array that needs to be still printed and make a recursive call to solve that part of the problem later, and I eventually want to reach a base case. So what is my base case going to be? Well, my base case is essentially the same thing as it was when I printed the array forwards. It was when my two indices kind of collide on each other. So when first equals last, that basically means I only have one element of my array left to print, so I can just go ahead and print it. That's my base case. And for my recursive case, what I want to do is I now again want to solve one small part of the problem, which is printing out some part of my array. But this time I'm actually going to print out the array at position last. So I'm saying, okay, I'm just going to solve a little part. That little part is printing the last element in my array. And then I can solve my reduced problem size by invoking this method recursively, sending in the same array. And actually, now that I'm working down, first isn't going to change, but instead last is going to be decremented. So this time I'm printing the last element in my array, and then my recursive call makes the problem size smaller by decrementing last. So as last gets smaller and smaller and smaller, it eventually will be 0, which will match first, so I'll eventually reach my base case. So I can now, again, I need to invoke this method from my original method. So I need to invoke the print array reverse helper, sending in the array. And what's the first index that I want printed? 0. And the last is, again, going to be numbers dot length minus 1. So if I invoke this, you see that it prints it in reverse. Okay, so there's some examples of 3 void recursive methods. Again, a void method is a method that doesn't return anything. And so when we invoke that kind of a method recursively, we just put a call in to invoke that method. A couple of things you always want to remember with all recursive methods, including void methods, is to have a base case and to have a recursive case. And your recursive case should always be moving you towards that base case with the recursive call. And then usually it will also complete some small part of the problem within the recursive case.